Hello everyone. I'm going to talk about the components of overhead transmission lines. A power system comprises three main components. From the previous classes, we might have understood those components. That is nothing but these generating station, transmission system, and distribution system. In each component, we require the conductors. We require the transmission lines to transmit power from one point to another point. So this can be carried out over long distances using the overhead transmission line. To design about a transmission line characteristics, we have to follow these characteristics. That is, the voltage drop should be kept as constant as possible over the entire length of the line. The line losses must be as small as possible in order to obtain high transmission efficiency. The copper losses, that is I square R losses, it should not overheat the conductor. These characteristics should be followed by some standards. So let us see what are those things. Components of transmission line. We have the components as conductors, supports, cross arms, insulators, and some miscellaneous items. So why do we need conductors? It has to carry power from sending end to receiving end. The sending end can be a generating station and receiving end can be a primary transmission substation, or this sending end can be a primary or secondary transmission system and receiving end can be a distribution system. So wherever the power has to be transmitted from one point to another point, we need conductors. Then supports. So why do we need supports? The support has to hold the conductor at a suitable level above the ground. That is, we should give proper ground clearance. There is a particular height between the ground and the conductor height. So those supports are said to be poles for low voltage levels and they are said to be towers for high voltage levels. Next, cross arms. These cross arms, it provides a mechanical support to insulators. Now, what is the insulator? Insulator, as the name says, it has to provide insulation to a high voltage wire with the metal structure. We have to give insulation to a high voltage transmission line conductor for safety purpose. And also it provides mechanical support to the conductors and other high voltage equipment terminals. So it will provide insulation as well as isolation. And miscellaneous items, we have face plates, lightning arresters, sometimes it is mentioned in surge arresters, V-arms, guard wires, anti-climbing wires, fuse, isolating wires, etc. So let us see these components one by one. Properties of conductor. So conductor, we know it should be a good electrical conduct. It should have good electrical conductivity. In turn, we can say that it should have low resistivity to have high current. And it should have high tensile strength. In turn, we should understand it should withstand mechanical stress. So it should be economical, it should have low specific gravity, and it should possess both electrical and mechanical properties, and it should fit for local conditions. So these things a conductor should satisfy. And once these can be satisfied, now we have to choose what material we should opt for choosing a conducting material. It can be cadmium copper, copper gold, phosphor bronze, and etc. etc. So practically we are using galvanized steel and iron when it is being used for long spans. Span is the distance between the supports, distance between the towers. It's the horizontal distance between the poles and towers. When the distance is more than 100 kilometers, we can say it has long span. So for those cases, we can go for galvanized steel and iron conductor. Practically, we are using steel core aluminum, that is ACSR, aluminum core steel reinforced conductor. Because copper is a good conductor, we know very well, but it is not available as plenty. But aluminum is available as 50, but it has less mechanical strength. So we can use both the advantages of this aluminum and copper, and hence we have come up with ACSR conductor. So if you are using this, we have less coronal loss, high tensile strength, these things. And disadvantages definitely be there, like skin effect. It can produce small sacs. It can deteriorate due to atmospheric conditions. And once we decided about the conductors, now how the conductor should be. It is not just like horizontal, long, straight conductors. The conductors will be twisted like this. See, we have one conductor twisted in clockwise direction, and in the next layer, the conductor should be twisted in the anti-clockwise direction. If I have one more layer around this, and it should be in clockwise direction. So alternatively, it should be twisted to give good flexibility. So these are said to be standard conductors. Now, if this is a standard formula to calculate the configuration of any conductor. If a conductor is configured as 7 power 2.24, I can say the 7 first value gives the total number of wires, and the second value 2.24, it gives the diameter of each strand. So how many layers I can calculate? This table will help us to do that. If I have number of wires 1 in the center, and the number of wires in the nth layer, maybe the first layer will be 6 times the n. So 6. So 6 plus 1, 7. So this 7 is filling this first column data. And how the diameter is fixed. So if I have 2.24, that is equal to 1 plus 2 into n into d. From this I can calculate the diameter of each strand, and hence the diameter of the total conductor. Like this we can calculate the conductor configuration. Then apart from these, we have to calculate how much a conductor can withstand its tension, whether it can be corrosive in different weather conditions, or how much it can withstand the vibration, how much loss can occur, or voltage drop can occur. So everything we have to keep it in mind to design a transmission line conductor. Once if every design is done according to the conductor material, now we should think about the voltage drop consideration. As per standards, it can have up to 5% maximum drops. It has to withstand maximum of 75 degrees centigrade, and by default it should be economical. Now poles, as I already told, it is nothing but support when it is for low voltage level. So the characteristics of poles will be, it should have low cost, it should have high mechanical strength, it should be light in weight, it should give us longer life, like this. And these are some types of low voltage poles. See, the first one is a low voltage, that is 415 volt, and the second one is a 11 kilovolt single member pole, and this third one is the 132 kilovolt pole, and this fourth one is also a 132 kilovolt pole. It depends upon the position of the conductors. We can frame this pole structure. So the choice of pole depends upon the span of the line, that is length of the line, cross-sectional area of the conductor, line voltage, cost, and local conditions. We can have these pole structures as wooden pole, steel pole, RCC poles, lattice pole. So this table column will give the comparison of these poles based on light, operating voltage, span, shape, application, and advantages and disadvantages. Based on the requirements, we can choose what type of pole structure we can go for. So these are some of the towers structure. Towers, nothing but the supports at high voltage level. And miscellaneous items, we have V-arms, face plates, those things are available, can be seen in this diagram. And again, towers, I can choose a narrow circuit I can choose a wide circuit. I can choose double circuit. See, I can have two sets of three-phase conductors. So you can see a tower like this, such that one set of three-phase conductors, say A, B, C, will be holding by these points, and another set of three-phase conductors A, B, C will be holded by these points, such that the second set of phase conductors can act as a duplicate phase conductors, such when these first set have to undergo some maintenance or some fault clearance, we can use this phase. Like this, we can see the towers having 6 conductors on either sides of the tower. And this is double circuit wide, and this is 400 kilovolt economical case, and this is DC transmission line, so that you can see only 2 conductors are required. And this tower seems like a cat head, and hence it is known as cat head line to avoid the clashing of 6 conductors, but the cost will be 2. Other accessories, fuse wire, again it is for safety purpose, clamps to hold the things, isolators, switches to isolate when the maintenance has to be happen, or to clear the fault, this isolator switch should open such that the transmission line get isolated, and surge arresters. So here the surge arresters, I can locate the surge arrestor like it can be, this is the transmission line, this is insulator, and this is surge arrestor. It can be suspended from the conductor like this, or it can be suspended from the insulator like this, or it can be suspended like from the insulator like along with the insulator like this, or it can be suspended upright from the cross arm like this. So this is the circuit diagram, and you can see all this in practical case. Insulator, so we can choose the type of insulator. We have seen the insulators is to provide insulation as well as isolation. We can go for shackle, pin, post, normal cap. Well, it depends upon the area or voltage. We can choose what type of insulators we need. And this is anti-clamping device. People like my students, they are very naughty. So we have to provide safety device, safety thing like this, such that they should not climb on the tower structure. So each tower or pole will have a anti-clamping device like this. Apart from these things, how to bother a boat, what tension it can withstand. As the year increases, the tension of the conductor will also increase, but its strength will decrease. So it is necessary to check the tension in the conductor often. So the tension in the conductor should be the breaking load, that is sag. So we have to keep on calculating this factor of safety at least in the maintenance phase. So as of now, we have seen the conductors, poles, tower, and can you see these conductors? See, these are white in color. It is not the conductor color. We have ice weights. We have ice covered the conductor. Here it is having wind. So the conductor will possess 3 types of weights, like its own copper weight, this ice weight, and this wind weight. Considering these 3 weights, we have to choose the conductor for our experiment. Thank you.